Hello children. So welcome to AIMS India's online classes. Today from mathematics subject quadrilaterals topic we are going to continue. So let's see the properties of a parallelogram, children. So for understanding the properties of parallelogram, so we are going to do one activity. With the help of this activity, we are going to tell the properties of a parallelogram. So we can draw a parallelogram with the below instructions. First step, draw any two intersecting lines OA and OB. OA, OB intersecting at O. So this OA and OB, this OA and OB are called intersecting lines. So first we have to draw OA and OB intersecting lines. So that is first step. So next, draw a line through B. Through B means from here. Draw a line through B and parallel to OA. Through B, parallel to OA, we have to draw a line. We have to draw a line. That is second step. Draw another line through A parallel to OB. Parallel to this OB, parallel to this OB, from point A, we have to draw a line through A, which is parallel to OB, which is parallel to OB. We have to draw a line through B, which is parallel to OA. We have to draw a line through A, which is parallel to OB. So this the parallel line which we have drawn from C and which we have drawn from A, let the parallel lines intersect at one point, which is named as C. Which is named as C. So then the figure formed by these 4 points, OACB or OABC, will be considered as a parallelogram. Will be considered as a parallelogram. So first, what we have done? First, we have drawn two intersecting lines. We have taken two intersecting lines, OA and OB. From B, we have drawn a line parallel to OA. From A, we have drawn a line parallel to OB. Both of them intersect at C. So then this OACB, whatever figure formed, this will be considered as a parallelogram. This is considered as a parallelogram. So in this method, we can draw different types of parallelograms. Either we have drawn this side. Suppose if we draw this side, if this OB and OA are the intersecting lines in this direction, so then from B one parallel line, from A one parallel line, so then this will be the parallelogram. So like that, in different sizes and in different directions, we can draw different parallelograms, like ABCD parallelogram, PQRS parallelogram, JKLM parallelogram, like that. So now, with the different measurements, we have to draw different types of parallelograms, and after that, we have to measure the sides and angles of all these parallelograms and results to be written in one table. So after drawing all kinds of parallelograms, let's measure the sides and angles of all kinds of parallelograms and record them in a table like this. Record them in a table. If you record all the values, AB value, CD value, AD value, BC value, if you record all the AB, BC, CD, AD values, so what you will observe? You will observe that AB equal to CD, AD equal to BC in the case of first parallelogram. Not only first one, in second case also you will observe PQ equal to RS and QR equal to PS. In third one also you will observe JK equals to LM and KL equals to JM. So these observations you will come across, you will notice. So these observations you will notice. If you measure the sides of all kinds of parallelograms, if you measure the individual sides of parallelograms, you will come to this conclusion. What is this conclusion? Opposite sides of parallelogram are always equal. Opposite sides of parallelogram are always equal. You can come to that conclusion. So if you measure the angles, of all these parallelograms, here this A, B, C, D, with the protractor, with the help of protractor, compass or divider, with the help of geometrical tools, if you measure the angles of these parallelograms, PQRS or JKL, M, these angles, so if you measure them individually, you will observe that angle A equals to C, angle B equals to D. So this A and C, this AC are equal, BD are equal, PR are equal, QS are equal, JL are equal, KM are equal, which means opposite angles of parallelogram are equal. Opposite angles of a parallelogram are equal. So from this first activity, what we have concluded, opposite sides of a parallelogram are equal with the help of this table, and with the help of this table, opposite angles of a parallelogram are equal. So which means opposite sides and opposite angles of a parallelogram are always equal. It may be any kind of parallelogram. That is confirmed. So next, let's do another activity. Activity 2. So draw 3 parallelograms and name them as shown. So one parallelogram has ABCD, another parallelogram PQRS, another parallelogram HIJK. So now let's draw their diagonals. Diagonals means the line joining of vertices, opposite vertices, which are not adjacent. The line joining of opposite vertices is called diagonal. AC is a diagonal, BD is a diagonal. So QS is a diagonal, PR is a diagonal, KI is a diagonal, HJ is a diagonal. And measure the diagonals and table them. So measure the diagonals and table them like this. So, and one more thing, let the diagonals intersect at O. All diagonals intersect at O. Now we have to measure in this first diagonal, OD how much, OB how much, OA how much, OC how much. That values we have to measure. OA, OC, OB, OD, we have to measure. If we measure, we observe that AO equal to OC, BO equal to OD, PO equal to OR, QO equal to OS, HO equal to OZ, IO equal to OK. Which means, so whatever diagonals are there, they have intersected at O. In which way? They are bisected. Actually, they are intersected into 2 equal parts. So we can call it as bisect. Intersecting into 2 equal parts is called bisect. So the diagonals are bisected. So the diagonals are bisected. So the diagonals of a parallelogram bisect one another. First diagonal will be divided into 2 equal parts. Second, 2 equal parts. Second diagonal also will be divided into 2 equal parts. So this is called bisect. So 2 diagonals bisect each other. And one more thing. So if we draw a diagonal, suppose this ABCD is there. If we draw a diagonal, it will divide the parallelogram into two triangles. It will divide the parallelogram into two triangles which are congruent, which looks like in the same manner. So each diagonal divides the parallelogram into two congruent triangles. Opposite sides are equal, opposite angles are equal, diagonals bisect each other. These are the properties of a parallelogram. These are the properties of a parallelogram. These are the properties of a parallelogram, children. So this congruent, how they are congruent triangles, this can be proved by this one, this small experiment. So consider a parallelogram ABCD. Let's consider a parallelogram ABCD. Draw a diagonal AC. Draw a diagonal AC. Now we have two triangles, ACB, one triangle, ACD, another triangle. We have got two triangles. So ABC, ADC or CDA. We have got two triangles in this angle 1 equals to angle 2. Why? Means this AB and CD are parallel and this line is the transversal upside, transversal downside. In the opposite directions angles are equal. So alternate angles, we call them as alternate angles. So 1 and 2 are equal. 1 and 2 are equal. Why? Because alternate angles. AD is parallel to BC. AC is the transversal. In the same way, 3 and 4 also equal. Alternate angles. And AC equal to AC, common side. So if we observe the two triangles, because of drawing diagonal, because of one diagonal, we have got two triangles in the parallelogram. If we compare the two triangles, this angles are equal, these angles are equal, and one common side is there. So one angle, another side are equal in two triangles. So this is called angle side angle property of congruence. So two triangles are said to be congruent. Two triangles are said to be congruent. So because of this property, ASA property, means triangle ABC is congruent to triangle CDA. Means almost they are similar. Almost they are similar. Next, if they are congruent, if two triangles are congruent, then remaining corresponding sides also will be equal. Angles also will be equal. Because for congruent triangles, corresponding parts will be always equal. So AB equal to CD, AB equal to CD, BC equal to DA, BC equal to DA. So these two triangles are equal. Already AC equal to AC common is there. So remaining two sets also equal. And we have this angle B equals to angle D. Here in this triangle angle B, in the triangle angle D. These angles also equal. These angles also equal. Similarly, if we draw diagonal through BD, we can prove that angle 1 is a triangle 1, triangle 2. If we compare triangles, we can prove that AB equal to CD, AD equal to BC, angle C equal to angle A, angle C equal to angle A. So by this proof, what are proved? This AB equal to CD, BC equal to AD, means opposite sides are equal. Opposite sides are equal. That is proved. And two triangles are congruent through ASA property. That is also proved. So two properties proved. One is opposite sides are equal, opposite angles are equal, two triangles are congruent. Two triangles are congruent. To prove that, another property that diagonals bisect each other. Diagonals bisect each other. Let's take this another proof. So consider a parallelogram ABCD. consider a parallelogram ABCD, draw diagonals, one diagonal AC, another diagonal BD, draw diagonals AC, BD. Let these two diagonals intersect at point O, So then in triangle AOB, we are comparing this triangle, AOB triangle, and OCD, this triangle. If we compare these two triangles, so AB equal to CD. So opposite sides of parallelogram, they are equal. And AOB equal to COD. Same vertex, opposite angles, vertically opposite angles. And this angle equal to this angle. Why means these two lines are parallel and this is the transversal. So this angle equals to this angle. So OAB equal to OCD. Why? Because alternate angles. So in this first triangle, in this second triangle, one side is equal, one angle is equal, another angle is equal. So according to angle, side angle property, so they are congruent to each other. This triangle, they are congruent to each other. In the congruent triangles, other corresponding parts also will become equal. What are the other corresponding parts? Only this side we have compared. So this side also will become equal. This side also will become equal. So OD equal to OB, OC equal to OA. Corresponding parts of corresponding congruent triangles. So this diagonal divided into two parts. This diagonal divided into two parts. So diagonals bisecting each other. This property also proved. Like this, children, with the help of theorems, we can prove all the properties of the parallelogram. We have proved all the properties of parallelogram. So now let's take in converse manner, in opposite manner. So for the above properties, let's consider in opposite manner. A quadrilateral, in properties what we have learned, if a quadrilateral is parallelogram, in parallelogram, diagonals bisect each other, opposite sides are equal, opposite angles are equal, and triangles are congruent. These properties we have learned. In converse, in reverse manner, how we can take the above statement means, a quadrilateral, if opposite sides are equal, then it is a parallelogram. If opposite angles are equal, then it is a parallelogram. If diagonals bisect each other, it is a parallelogram. If it has one pair of opposite sides parallel and equal, then it is a parallelogram. So like that, in reverse manner also, we can take with the help of properties, we can prove that it is a parallelogram. If it is parallelogram, we can prove the below properties. If below properties are true, then we can prove that it is a parallelogram. We can do in any way. Next, let's see some example problems. So, ABCD is a parallelogram. Angle A 70 degrees. Calculate BCD. So, angle A plus angle B. So, adjacent angles in a parallelogram are supplementary or co-interior angles, because these two are parallel lines. This is the transversal. Then these two AB angles will become co-interior angles. So they are supplementary. So A plus B 180. So which means 70 plus B 180. B equal to 110. If B is 110 degrees, in parallelogram, opposite angles are equal. If this is 70, this is also 70. If this is 110, this is also 110. So like that, we can prove. We can find all the angles if one angle is given. Next one, example 2. The adjacent angles of a parallelogram are as 2:3. Find the measures of all its angles. Find the measures of all its angles. So here children, ABCD is a parallelogram. Adjacent angles of parallelogram in the ratio 2:3. Means one angle we can assume it has 2x. Another angle we can assume it has 3x. These 2x and 3x are adjacent. So let A equal to 2x, B equal to 3x. So then these two, A and B, will become co-interior angles, which are supplementary. So A plus B 180 degrees, 2x plus 3x 180 degrees, 5x 180 degrees, x 30 degrees. A equal to 2x, 2 into 36, 72. B equal to 3x, 3 into 36, 108 degrees. If A is 72, then C also equals to A. If 3x is 108, then D also equal to 108. So C and D also we can find. Next one, example 3. The ratio of two sides of a parallelogram is 3:5. Its perimeter is 48 centimeter. Find the sides of a parallelogram. The symbol for parallelogram is two lines we can draw, two long lines we can draw, and we can write ZM in words, which means it's a parallelogram. It is a shortcut for the word parallelogram. So in a parallelogram, the ratio of two sides given, perimeter given, we have to find the sides. If the ratio is 3:5, then the sides will be, one will be 3x, another will be 5x. So, but opposite sides of parallelogram are equal. If the adjacent sides are 3x and 5x, if the adjacent sides are, one is 3x, another one is 5x, then other two sides also will become, this is 3x means this is 3x, this is 5x means this is 5x. Other two pairs of adjacent sides also will become 3x and 5x. But perimeter, sum of all lengths of all sides or circumference is 48 centimeter. Means 3x plus 5x plus 3x plus 5x equal to 48. 16x equal to 48. X equal to 3. So the sides are 3 into 3, 9, 5 into 3, 15. Other two also 9 centimeter, 15 centimeter. Next one. Fourth question. On Mitchell. The point of intersection of diagonals of a quadrilateral divides one diagonal in the ratio 2:3. The point of intersection of diagonals of a quadrilateral means we have a quadrilateral ABCD, which is not parallelogram. They have not given here. It's just a quadrilateral. The point of intersection of diagonals divides the diagonal in the ratio 2:3. Means if this is one diagonal, this point of intersection of O divides this BD diagonal in 2:3 ratio. Upside part 2 parts, downside part 3 parts. This AC also, downside part 3 parts, upside part 3 parts, or any one part. One part 2 parts, one part 3 parts. Like that it has divided this point of intersection. It has divided the diagonals in this ratio. So is it a parallelogram or not? Why? Why not? So how the diagonals are divided? In the ratio 2:3. But In parallelogram, the diagonals are bisected. This part will be equal. Means point of intersection will be dividing the diagonal in the ratio 1:1. Then it will be a parallelogram. But they have given 2:3. So this is not a parallelogram because the ratio of diagonals, the ratio of division of diagonals is not in the ratio 1:1, or diagonals, the parts of diagonals are not equal, so it is not a parallelogram. Next one. In a parallelogram ABCD, diagonals AC and BD intersect at O. So AC equal to 12.8. AC equal to 12.8. BD equal to 7.6. Then what about OC and OD? What about OC and OD? OC and OD. So here they have given the value of AC, one diagonal, BD, second diagonal. We have to find OC, part of one diagonal, OD, part of another diagonal. We know that OA equal to OC, OA equal to OC, or OC. OC is nothing but half of this AC. OC is nothing but half of AC diagonal. OC, half of AC, half into 12.8, 6.4 centimeter. And OB equal to OD. So OD equal to half of BD. OD equal to half of BD, half into 7.6, 3.8 centimeter. Next one. Next question. The perimeter of a parallelogram is 150 centimeter. One of its sides is greater than other by 25 centimeter. Suppose if one side is x, another side is plus 25. 25 centimeter greater than x, x plus 25. So opposite sides are equal. If we know these two sides, this opposite will become x, this opposite will become x plus 25. So all four sides are x, x plus 25, x, x plus 25. Their sum is 150 centimeter. Actually their sum is, if we add all, we will get 4x plus 50. But in the question they have given it is equal to 150. 4x plus 50 equal to 150. 4x equal to 150 minus 50, 100. X equal to 4 comes downside. 100 by 4, 25. So lengths of all sides are, one side is x, 25. One side is x plus 25. Means 25 plus 25, 50. If two sides are 25, 50, other two sides also will become 25, 50. So these are the sides of a parallelogram. Next one. So diagonals of a parallelogram ABCD intersect at O. Intersect at O. Actually diagonals are, this AC and BD are diagonals. They intersect at O. XY line also contains O. XY is not the diagonal. It is another line which consists O. And XY are points on opposite sides of parallelogram. These XY are points on opposite sides of parallelogram. X is located on one side, Y is located on another side. So give reasons for each of the following statements. Why OB equals to OD? So now why OB equals to OD? So why OB equals to OD? Diagonals intersect each other. Diagonals bisect each other. So that's why this OB equal to OD. That is the reason. Second one, OBY. OBY, this angle. ODX. ODX, this angle. Why these two angles are equal? Because this AD line is parallel to BC line, and this is the transversal. This is the transversal. Transversal this side, transversal this side. Alternate angles are equal. So that's why they are equal. That is the reason. Why these two, BOY, BOY, DOX, DOX. Why these two are equal? Same vertex, opposite angles, vertically opposite angles. So that's why they are equal. Next, BOY, DOX. Why they are congruent? BOY, DOX. This triangle, this triangle. Why they are congruent? Why they are congruent? Why they are congruent means OD equal to OB because diagonals bisect each other. Just now we have proved this angle equal to this angle and this angle equal to this angle according to ASA property, ASA congruence. According to ASA congruence, they are congruent triangles. They are congruent triangles. Now, XY is bisected at O or not. So now, because this first triangle, this second triangle are congruent, remaining corresponding parts also will be equal. Means OX equal to OY. OX equal to OY. Means not only diagonal, any line passing through the point of intersection O will be bisected by the point of intersection. So OX equal to OY. So XY is bisected by O. So like this we can prove, we can give the reasons for all the questions children. Okay children, because we have explained almost all examples children from the textbook part. Because we have explained all the examples now. So exercise problems in textbook, if any exercise problems are there means based on these concepts and example problems, you can solve them. Okay children. Okay, that's all for today children. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. So you can also visit our website children, www.aimstoday.in, for other information regarding online classes, quizzes, worksheets, activities, English classes, coding classes. Thank you children. Have a good day.